Hello, everybody, and welcome to my class. Today, we will be talking about functions again. And this is the seventh grade curriculum. And for those, most of you have been to my last class, so you should know the material, but some people have not been to my last class. So I'll start with a review. So this might be new. To those who have not been to my last class, but this will be review for the ones that have been to my last class. So our schedule, of course, we're starting with a review. Next, we're going to scatter plots and trend lines, and then writing equations of trend lines. And in this third section right here, writing equations of trend lines, I did a math session a couple classes ago about the different ways of graphing linear equations like slope-intercept form, point slope form, and standard form, and you will have to know them when you are writing equations of trend lines. So I'll review them when we go to that section. So are there any questions about the schedule? Any questions or concerns? Okay. What do I mean by a scatter plot? Okay, I'll explain what a scatter plot is later on. But basically, it's just a set of plotted points, okay, that show the relationship between two sets of data. Okay, so let's review. What is a function? A function is a relation where each input has exactly one output. Okay, a relation is the correlation between an x value and y value. And x will be the input while y will be the output. Now x, as a lot of you know, that x might not always be the input because when you're working with real world problems, x will be the independent variable, and then y will be the dependent variable. Okay, so let me give an example. This is x and y. Okay, this is the input. The output is right here. Okay, so let's have a few input values and output values. Okay, 3 maps to 4, 3 maps to 5, 4 maps to 6. The warm-up question, is this a function or not? Is this a function or not? Okay? You have some answers. Okay, no answers, but yes. So Sophia, yes, the functions are like time and money. So time obviously being the independent variable because you can't stop time. It's independent. While the money you earn if you like work regularly, then you can that would be money would be the dependent variable. Okay, very good, Sophia. And W iPad. What do I mean? What do I mean on what? Okay. Anyways, the warm-up question I'm wanting you guys to do right now is to figure out if this relation is a function. Each input has to have exactly one output. So, okay, I'll walk you through this one then. So we have two inputs actually, just 3 and 4. But 3 maps to 2 outputs. And you see in the definition here, each input has to have exactly one output. Okay? Has to have exactly one output. And here, 3 has 2 outputs. That is why this relation is not a function. So let's do another warm-up question, and then we'll move on to one-to-one functions. Okay, so 2, 3, 4. 2 maps to 2, 3 maps to 4, 4 maps to 7. Okay, is this a function or not? Is this a function or not? So please put in the chat your answer. I hope everybody will participate in this to show your understanding of functions. Okay, Sophia says no, it is not a function. This is not a function. Why it is not a function? Okay, can anybody explain why this is not a function? Why it's not? Any explanations? If no, then I'll walk you through it. This is, in fact, a function. This is a function. Now why? Because each input you see has exactly one output. This is a function. 2 maps to 2, 3 maps to 4, and 4 maps to 7. That's totally fine. So this is a function. Now, if it was 2 maps to 2 as well as 2 maps to 4, then 2 maps to 2 inputs. Okay, 2 outputs, I mean. Okay, the input 2, if that maps to 2 outputs, 2 and 4, then that is not a function. But this, where each input maps to only one output, then this is a function. Okay, so one-to-one functions. One-to-one functions are functions where each output has exactly one input. Okay, it has to be a function first, where each input has to have exactly one output. But then the output has to have exactly one input. Okay, so let me clear up this definition. Okay, so as you see, this is a function, right? This is a function. Okay? This can be, use another one. Okay. Is this a function? Yes, it is a function, but not a one-to-one function. Because this is a function because each input only maps to one output. Okay? So 3 maps to 5, 4 maps to 5, 5 maps to 6, 6 maps to 7. This is totally fine. However, there is an output 5 that has 2 inputs, 3 and 4. That is why it is not a one-to-one function. If you see an output that appears twice or even more in a function, then that is not a one-to-one function. Same with just finding out if a relation is a function. If there is an input that occurs twice or even more in this relation, then this relation is not a function. Okay, let's do a warm-up question. Is this a one-to-one function? Is this a one-to-one function? You already know that this is, in fact, a function. Now I just want you to know that if this is a one-to-one function. Okay, please put your answer in the chat box. Okay. Okay, Sophia says she thinks it is a one-to-one function. Are there any more answers? Okay, any more answers? Okay, no more answers? Then I'll walk you through. As I said, if an output occurs twice, then it is not a one-to-one function. Because the definition of a one-to-one function is where each output has exactly one input. Okay? So 5 maps to 6 and 7 maps to 6. That's a function because each input only has one output. However, the output 6 has 2 inputs. So it is not a one-to-one function. It is not a one-to-one function. Okay, do you understand now? Sophia, do you understand? Or anyone else who got it wrong? Okay. Are there any questions on this? Okay, yes, you understand. Then I'll move on. Okay, next. I'm going to explain interval notation and the vertical line test and the horizontal line test. Okay. So first I'm going to explain the vertical line test. Okay. So I'm not going to explain interval notation. First I'm going to explain the vertical line test. So for those who have been to my last class, you know what the vertical line test is. Okay. It is just drawing an infinite amount of vertical lines. Okay, infinite amount of vertical lines. Okay, and if any of these vertical lines intersects the graph more than once, then this relation is not a function. Okay, so for those, as you know already, functions can be graphed, right? Okay, you have a set of x and y values. Okay, they can be graphed. But you want to know if these are actually functions. If these are actually functions. Okay, you see here, if you draw an infinite amount of vertical lines right here, I think this intersects the graph a lot of times. Okay, this line right here. Okay, so this is not a function. Now I'm going to explain why the vertical line test works with finding out if something is a function or not. So you see here, if there's an x value, let's say 3, for example, in this particular example right here, there's an x value of 3 that maps to 2 y values. Okay, let's have 3 right here, about here, right? And that maps to 4 and 5, right? 4 and 5, okay? Maps to 4 here and 5 here. If it maps to 4 and 5 here, okay, then those will be the points, okay, graphed. And if you draw a vertical line through them, then that vertical line intersects those both of those points. That is why the vertical line test works. Because if you have one x value that corresponds to 2 y values, then a vertical line will definitely pass through those 2 points. Now, there's something even more restrictive than the vertical line test, and that will be the horizontal line test. And this, okay, is like the title says, drawing an infinite amount of horizontal lines. And if any of those horizontal lines intersects the graph more than once, then it is not a one-to-one function, okay? This horizontal line intersects this graph, okay, twice, then that is not a one-to-one function. And the reason that the horizontal line test works is very similar to why the vertical line test works. Okay, here you see we have an output 5. You have an output 5 that corresponds to the inputs 3 and 4. That is totally fine because it is a function, but not a one-to-one function because this output 5 does not have exactly one output. It has 2 outputs. I mean inputs. Okay. So let me repeat. Okay. This output 5 has exactly 2 inputs. Okay, if this output 5 had 1 input, then that would be one-to-one function. But here 5 corresponds to 2 inputs. That is why it is not a one-to-one function. Okay, so we have the output 5, right? And outputs, remember, are y. Okay, so this is 0, 5, 5 on the y-axis, and that corresponds to what? 3 and 4. The inputs 3 and 4 should be right around here. Okay, so if you just connect these, graph them, okay, you get some points that are right here. You just graph those points. And of course, this fails the horizontal line test. So that is why the horizontal line test works. Okay? So, before I explain interval notation, I'll have to explain domain and range. So domain and range. You see these relations over here, these functions? Okay. So basically, domain is the list of all the input values, all the x values, or all the independent variables, all the independent values, okay? So you see the domain of this particular function right here. This would be 2, 3, and 4, right? The domain of this, 2, 3, and 4, okay? Because that's the list of all x values. Now the range, okay? Domain and range. The range, like the domain is the list of all y values. So the range right here would be 2, 4, and 7, okay? Quite easy, right? Except when you have a very large table of all these numbers, then you're not going to possibly list all of them, right? You're not going to list all of them. So that is when interval notation comes in handy. Okay, so interval notation is basically so you have this domain, right? From -20 to 10. Those are all domain values, right? They're all x values. But we can't list all of them, right? They're infinite ones, okay? They're infinite decimals, even between -20 and -15. Infinite. So it can't possibly list them. That's why we are going to say from -20 to 10 is all domain values. From the least x value to the greatest x value. That's our list, okay? From -20 to 10. Those are all the x values. And right here, you use parentheses, okay? And that's how you do it in interval notation. Now, why we use parentheses is because this circle right here means this is an open circle, okay? This is an open circle. And when you have open circles, okay, it means that these points are not actually on the graph, okay? These open circles, okay? Open circles denote that these points are not actually on the graph, they're elsewhere. So that's why we use parentheses. Let's say these were arrows. If these were arrows, then that means these ends will extend infinitely to these will extend to infinity. Then of course, if infinity is not even possible to be on this graph. So that is why if these were arrows, we would also use parentheses. Now, if these were closed circles, these are closed circles, then that denotes that these points are in fact on our function here, okay, on our graph, okay. Then we will use square brackets, okay. We use square brackets if these points were closed circles, okay, right here. Now, Okay, our range. Okay, starting from our least range value to our greatest range value. Okay, so our greatest range value would be 24, right? It's 24, the highest range value. But our lowest would be 0, right? This appears to be 0, and it's on the graph. Okay, if this is on the graph, okay, we use square brackets. So 0, and then 24. Now what comes next? Parentheses, right? Because you see, 24 right here, this is an open circle. This is not actually, 24 is not actually on the graph. So we might get something like this, square bracket and a parenthesis. So pay attention when you're using interval notation, so you don't get it incorrect. So now let's do our next one, okay? So please do the next one on your own, okay? This one. Okay, and post your answer in the chat. Okay, please start. Okay. And Sophia, what OS am I using? Okay. What does OS mean? No, seriously, what does OS mean? I actually don't know that. Okay, and anyways, any more answers? Okay, no answers yet. So operating system. Okay. I'm using an iPad, Apple iPad. Okay, wait, no. Actually, it's a Samsung tablet, not an iPad. Samsung type tablet. Okay, so if no answers, then I'll walk you through it. Remember, domain is list of all the x values. Our least x value is -8 over here. Okay, but that's not actually on the graph because that's an open circle. -8, 2, -2 because that's our greatest x value. But -2 here is actually on our graph here. So that's a square bracket. Next, we have our range. Okay, -4 here is our lowest range value, but that's not on the graph. So parentheses again. Okay, -4, 2. Our highest range value, which is 2. But okay, I did it wrong here. That is not a parentheses. That is a square bracket because this point right here is a closed circle, right? It's a closed circle. So that means that this range value right here is on the graph. Okay, this point right here is on the graph. That's why we use square brackets at the end. So lastly we'll review function notation. So function notation, okay? Function notation. Okay, so what is function notation? It's basically, okay, it shows the relationship between the input and the output. Okay, shows the relationship between the input and the output. So here we have an example here. This example, this will be the output, and x here will be the input. So what this is basically saying, okay, ignore this f right here. It just denotes that this is an function. Okay. So f of x. Okay, x is the input. You can put any number in there. That's the input. So if you put a number in there, then the output will be 4 times your input, which is x, and then add 1 to it. Okay, so let's say we have our input is 4, okay? Then our output would be 4 times 4 plus 1, which equals 17. So if our input is 4, then our output would be 4 times 4 plus 1. Okay. So basically the output is 4 times our input plus 1. So are there any questions on this function notation right here? Okay. Carney, it does look pretty weird with parentheses and square brackets, but that's how it is. Okay. So, let's go on to scatterplots. So I think Sophia, you asked this uh in the beginning of the class. So here, I'll show you what a scatterplot is. Okay. So a scatterplot definition is a graph of plotted points that show the relationship between two sets of data, right? I explained that earlier. Okay. So here is what a scatter plot will look like. So basically, if we have a plot, kind of looks like this, right, with a line through it. But with scatter plots, that isn't the case. Scatter plots, like I said in the definition, is basically just a graph of plotted points. It's like this. That's basically a scatter plot. It is a graph of all these plotted points. We have an x and the y right here. Okay. Okay. It's just a graph of plotted points with sometimes we have a general order. Okay. Right here it's kind of going up in that direction. But sometimes there is really no direction of it. It's just everywhere. Okay. These points are everywhere. And then I'll explain what this means later when we're talking about types of association in scatter plots. So basically this is a scatter plot. Okay. Okay. So now let's look at trend lines. Trend lines are lines that model the general course of a set of data. So look here, right? We can't actually draw a perfect line through all these points, right? If we had a linear equation, of course we could draw a line, right? It's a linear equation. We can draw a line. However, with scatter plot, we can't really draw a line all through all these points. So what we do is we draw a trend line that models all the data, all the sets of data. Okay. So all the points, they're generally going up in this direction here, right? So we draw a trend line to model the general course of these plotted points. Okay. So that is basically what a trend line is. Okay, so now let's start interpreting trend lines. Okay, I'll teach you how to interpret trend lines. Okay, so you see here we have a trend line. Okay, and there are interpreting data. Okay, so basically what I want to talk about on this specific slide is the types of association in a set of data. Okay, so we have, let me just list out all the types of association. Number one, there is positive association. Number two, there is negative association. Number three, there's just no association. So let me explain what this means. Let's go back to this specific slide here. Okay, so this shows a positive association. Why? Because, and this is very important, so make sure you understand this, because in a positive association, x values are increasing. You see, x values are increasing right here. And while x values are increasing, y values are increasing. Okay? So that is why this set of data shows a positive association. Okay. Now, if the data is like this, going like this, right? Okay, you can have a trend line models it, okay? And you see x values are going up and y values are going up as well, okay? Then this would be a positive association. And let me just clarify. If x values are decreasing, okay, if x values are decreasing while y values are decreasing, then that is also positive association, okay? If it's like this, okay, right here, you see x values are in the negative as well as y values are in the negative. So that also works. Okay, so both these scenarios are positive association. Okay, now what about negative association? Okay, some of you might have guessed it. Negative association are when y values increase while x values decrease. Okay, so y values are increasing while the x values are decreasing while y values are increasing. Okay, so this shows negative, and of course, uh, this also works. Okay, so let's say x values are increasing while y values are decreasing. So, okay, so x values are increasing, y values are decreasing. Okay, this one is actually x values increasing, and this one is y values decreasing. Okay, sorry for that mistake. Okay, but when we have y values increasing while x values decreasing, okay, we have something like this. Okay, so right here we have this scenario. Yes, this is the same scenario because uh, x values are in fact increasing in this scenario and y values are decreasing. In this, on the top here, okay, uh, x values are decreasing while y values are increasing. So that is also negative association. So as like positive, there are positive association. There are two scenarios that can be negative association. Now, as I said earlier, now I was talking about scatter plots. Some scatter plots have no association, no pattern whatsoever. Okay, no pattern whatsoever. Okay, they're just like all over the place, all over the place. There is no pattern whatsoever. Then you can't classify it as positive or negative, so you just say no association. Okay, this would be no association. Okay, that would be no association. Okay, so are there any questions? If you have any questions, please put them in chat box. If not, Okay, 3 comments already. Okay, I'm glitching. Okay, maybe that's your Wi-Fi problem. Uh, is anybody else having any problems with the glitching or? Okay, Sophia, is there a website where I learn all the stuff I'm teaching or talking about? No, there really isn't. A website is. It's one of my online extracurricular classes. I learned it a long time ago. This is part of the easier uh sections of the extracurricular class I'm taking. So I'll just teach it to you guys. Okay. Learned it a long time ago. It should be your love. Okay. Anyways, so no questions. Then let's go on to some practice problems. So number 1 is, what association does this particular set of data show? Okay, what association? So please put your answer in the chat. This should be quite a fast answer. Okay, so okay, Barney, positive, right? You put that in a very interesting way. Positive. Okay, Carney says positive association. Okay. Any more answers? Any more answers? Very nice, Carney. Okay. Any more answers? Are there any more answers? Okay. Frank, Sophia, any more answers? Okay. Who's here? Okay, Genevieve. I don't feel like I've heard from you yet. Okay. Are there any answers? More answers? No? Then I'll walk you through. See here? You kind of draw this trend line, right? Kind of draw this trend line. And you see here, the x values are increasing, right? While the y values are also increasing. So this shows positive association. Okay, and before we move on to the next one, I want to clarify something else. Okay, we sometimes have data like this. Now, okay, you see this is kind of like a U shape. Okay, it's a curve, right? And we can't really draw a trend line, right? Okay, trend lines are lines, they can't be curves. So when we have data like this, we just call it non-linear, okay? This is non-linear data, okay? A non-linear association, okay? I just wanted to clarify that before going to the next problem. But most of the problems will just be on positive, negative, and no association. Okay, so our next set of data. So what association does this set of data show? Okay, please put your answers in the chat. Okay, I'll give you a few moments and I'll leave this slide up for a few moments. Okay, and I hope you'll all participate and answer. Shouldn't be too hard. Okay, negative. Very good, Carney. Okay, and W iPad, negative as well. Okay, very good. Are there any more answers? Okay, Sophia, says negative. Very good. 3 answers. Now, very nice. And this is negative association. Put a line through here. My line isn't too perfect, but you see here, y values are decreasing while x values are increasing. So this is negative association. So, okay, this is negative association. Very good. So now let's start writing equations of trend lines. And okay, so I need to ask everyone, does everybody know about point slope form and slope intercept form? Okay. Okay, yes, Carney. Okay, so any more answers? Does everybody know about okay, slope intercept form and point slope form? Okay, very good, Carney. You were at all my classes. That's very admirable. Okay. Uh, so y equals mx plus b, right? Okay, very good. That's slope intercept. Okay, Carney, do you know what point slope form is? Point slope form. Okay. You think? Very good. So, if not, then I'll review when I get to them. So basically, you want to use point slope form when you're writing, okay, the equations of your trend lines. Okay. So, let's see here. So when you're writing equations of trend lines, you need to use point slope form, which is y minus y1 equals m times x minus x1. So does this look familiar to anyone? Does this look familiar? Okay, yes, very good. Okay, so Sophia, do you know this one? Point slope. Okay. You don't know, okay. So does anybody else don't know? I'm going to review it if you don't know. Okay. So this is point slope form. Basically, y and x are the y values and x values of points. Okay. They're the y value and x values of points. So let's say we have this point 3, 4. This would be y1, that's the y value, and this is the x1. X and y, not x1 and y1. The x and y are just general points. You don't fill them in or substitute them in for anyone. So m here is the slope. M here is the slope of our trend line. So let me give an example. It might clear up your understanding of it. So let's use just this point, 3, 4, and another point, 5, 6. Okay, so does anybody know how to find slope from 2 points? Okay. Carney, do you know how to find slope from 2 points? I think you do know. Uh, okay, you're getting your notebook. Very good. So for those who don't know, okay, for those who don't know how to find slope from 2 points, then it's basically vertical change over horizontal change. So y over x. So it's basically y2 minus y1 divided by x2 minus x1. Okay. So we have our y2 right here and y1. Both x values, and you have to subtract them. Subtract them. Okay, y y2 is 6 minus 4, okay, which is 2, over x2 and x1, okay, subtract them, 5 minus 3 equals 2, again, 2 over 2 equals 1, okay, so our slope is 1, m equals 1, very good, okay, so, so next, we have to, substitute y1 and x1 for actual numbers. And you can use any of these points, okay? We have 2 points. So let's just choose 1 point, okay? So 3, 4, okay? Let's choose 3, 4. And 3, 4, the y1 will be 4, right? And x1 will be 3, right? So let's substitute it in. Y minus y1, which is 4, equals m, which is 1, times x minus x1, which is 3. Let's simplify this. Y minus 4 equals x minus 3. Okay? Now, let's move our 4 back here. Y equals x plus 1. Then we just converted it to slope-intercept form, right? And this right here is the equation of our trend line. Okay? So does everybody understand? Okay. Okay, does everybody understand? Okay. Are there any questions on that material right now? Okay, Carney understands. Very good. Okay. So now, if you are going to write the equation of a trend line, they're not just going to give those 2 points to you, are they? Okay. If you're taking an exam, okay, or analyzing actual data, and let's say you're doing a job or something, okay, they're not gonna give you the actual 2 points that it like passes through, okay? So in our trend line, we have to approximate, okay? We have to approximate, okay? If we have a graph right here, we're writing the equation of our trend line, okay? And this trend line represents all the data. We can just use 2 specific points from the data. That will not work. So we'll have to use specific points on the trend line, okay? Okay, that was a mistake. On the trend line. On the trend line. Oh, okay. I'm being called by my little brother, so I need to go for a few moments. He's screaming as loud as an elephant. So, okay. Few seconds. Okay, sorry for the disturb. Okay, I'll be back in 5 seconds. Okay, I'm back. Okay, uh, so you have to find these points yourselves. Okay, and we have our points. Okay, right here. We you have to actually put these points on the trend line. If there isn't a plotted point actually on this this trend line, okay. So, but in this case, I want your answers to be exact, not approximation. So I'm actually going to give you the 2 points. So, let's go to our practice. So, number 1, okay, this is pretty difficult, but I'm sure you can do it. Okay, number one is a set of data shows the attendance, okay, in millions of amusement parks in a particular country, okay. If the trend line passes through the points 1990 to 254, okay, 1990 is the year, 254 is the attendance in millions, and 2002, 323, write the equation of the trend line. Okay, I'll give you 2 points right here, 2 points in this one. Okay, and the x-axis, okay, that's the year. Okay, the y-axis is the attendance. Okay, so the year is the independent variable, while the attendance is the dependent variable. Okay, so please write the equation of this line right here. Okay, I'll give you a few minutes. Okay, so please put your answer in the chat box. I'll leave this slide up for a few moments. Let me check if there are any comments. Okay, a lot of comments. Okay. So please put your answers in the chat box when you're done. Okay, you don't know. Sophia, Carney, are you working on it, Carney? You know how to do it, Carney, I think. Okay, Carney, yes, you are working on it. Very good. Then I'll wait for your answer. Are there any other people that know how to do it? Okay. Any other people? Okay. Then I'll wait for Carney's answer. Okay. 12/69 is your slope. Are you sure that's correct? 12/69 is your slope. Okay. Okay. Sophia also agrees with 12/69. Are you sure it's not 69/12? 12/69 or 69/12. Those numbers are correct. Okay? But are you sure it's 12/69 or is it 69/12? Okay. Sometimes get it mixed. Okay. Then I'll walk you through it. But very good work, Carney, on getting the slope, or at least the numbers of the slope. Okay. So we have 190. Those are our two x values. So our y values are actually 254 and 323. So 323 minus 254 over the x values, which is 2002 minus 1990, which equals 69/12. Right? So 323 minus 254. Yeah, that is 69/12. Okay? And that let's simplify to 5.75, right? That's 5.75. Okay? So 5.75 is our slope. Now we just have to substitute in one of the points, right? So in our point slope form, okay? So y minus, okay, let's use this first point I gave you. Okay, so what is the y1? Okay, y1 is 254, the y value of that point, okay? And that equals m, which is the slope, which is 5.75 times x minus our the x value of our particular point, which is 1990. Okay, and we have this. So y minus 254 equals 5.75x minus 5.75 times 1. Okay, that would be I think 11,442.5. Okay, but then you have to move this negative 254 to this side. Remember, use inverse operation. So basically, just add to a negative 11,452.5. Okay, so add 254 equals y. Okay, y equals 5.75x minus 11,188.5. Okay, so that is the equation of our line. So very good, very good. Okay. Okay, so Sophia, why do I do it like this? What do you mean by why do I do it like this? Basically just the y values. Subtract the y values, okay? Okay, the bigger y value, subtract the smaller y value, and the largest x value, subtract the smallest x value. It's just like that. Okay. Okay, so our next problem. We still have a few more minutes. So, number 2 is using the equation of the trend line. Okay, you found in the previous problem. Estimate the attendance in theme parks in the country in 2005. So, there's not much time left, so I just walk you through this one. Okay, so our equation is y equals 5.75x minus 11,188.5. Now, x should be the year, right? And y is going to be the attendance. X is the year, okay, 2005. So what we do here to find the attendance, to estimate the attendance, we're just going to plug in 2005 for x, right? Okay, so that's what we're going to do. Now, get your calculators out. Let's do this. Okay, so 5.75 times 2005 is going to be 11,528.75. Okay, minus, okay, 11,188.5. Okay, minus. Let me do it again. Okay. Okay. So, next, we're just going to get y equals 340.25. million. Okay? So that is how we do it. Are there any questions on this particular problem? Yes, my YouTube channel is my name, just my name. Okay. So that was our last question. So thank you for listening, everyone. And if you enjoy this class, please come to the next one. Okay. So bye, everyone. Thank you for listening.